All right. So, hello everybody. Welcome to POODR Chapter 4, Creating Flexible Interfaces. I'm Mary-Katherine McKenzie. I'm sort of new to Ruby. Still learning a lot. Clayton, do you want to introduce yourself?
Yeah, I'm Clayton Flesher. I'm also fairly new. I deployed my first app this week.
Cool.
So,
congrats.
yeah, got my first domain and everything.
Nice. Ferris, you're going to be able to talk. Do you want to introduce yourself, or are you just listening?
You know what? I'm going to just listen because my kid's still talking.
Okay, that's fine. Clayton, do you want to introduce yourself? Hold on. I'm getting feedback. Okay. Jason, do you want to introduce yourself?
Sure. My name is Jason. I'm a newbie. I'm gonna figure out this POODR stuff. Yeah, that's about it.
Cool. Okay, Victor.
Hi, I'm Victor. Not new to code. Been around code for years, mostly on server side. I'm trying to learn Ruby and Rails for web apps and stuff.
Cool. Nice. It's nice to have a varying degree of experience. Okay, so I'm going to go ahead and share my screen. Go ahead and get started. All right, can you guys all see that?
Yep.
Cool. Okay, so here's the title again. And I like to start with the summary. The summary is actually the last paragraph, but I mean it's a great summary. So, object-oriented applications are defined by the messages that pass between objects. This message passing takes place along public interfaces. Well-defined public interface is consistent. Sorry, I also let me take a break from that real quick. I also typed this entirely by dictation, so it probably didn't type correctly.
All good.
Okay, where are we? Well-defined public interfaces consist of stable methods that expose the responsibilities of their underlying classes and provide maximal benefit at minimal cost. Focusing on messages reveals objects that might otherwise be overlooked. The messages are trusting and ask for what the sender wants instead of telling the receiver how to behave. Objects naturally evolve public interfaces that are flexible and reusable in novel and unexpected ways. So the first part was about understanding interfaces. Does anybody want to take a crack at explaining what this diagram is about? Clayton?
Sure. Yes. So each one of the each one of the spheres represents a class, and the one on the left. Let me make it so I'm only seeing your image. The one on the left is each object sends a bunch of messages and gets a bunch of messages, or knows a bunch about, and it's not messages yet, it's knowledge about. Knows a bunch about a whole lot of other classes, and a whole lot of other classes know about each one of those. So the communication between them is highly coupled. And then the ones on the right, each one is sending out messages, and the other objects only need to know about one or two other objects, or there's some kind of intermediate object. If you're going to have to know about 3 or 4, like the southwest quadrant one there, it knows about 3 other objects. It's probably acting as some kind of intermediate wrapper. So the one is sending a message, and then that one is sending out 3 messages to 3 other things. It's just making it so that there's a whole lot less interdependence between all of the different objects. So there's actually the exact same number of classes and objects, but they know a lot less about each other and are sending a lot less information back and forth.
Yeah, exactly. So basically she says the first one is like an interwoven piece of cloth and you can't pull them apart, but the second one you can reuse the individual pieces. So we've got that. The next section was about defining interfaces, and she uses this kitchen and restaurant metaphor. So basically she says, you know, the customers order off of a menu, that's a public interface, the kitchen prepares the order, that's a private interface. To the customers, it just looks like they send a message, you know, an order back to the kitchen, and what they want magically appears. They don't need to see all the mess in the kitchen, and that's kind of the same principle. And she also, there's a quote, even though they ordered it, customers are not welcome to come in and stir the soup. So, you know, that would be weird. So she also defines kind of what the difference between public and private interfaces are. So public interfaces are basically like a list of responsibilities. They reveal its primary responsibility. Public interfaces are expected to be invoked by others. They probably won't change, so they're safe for others to depend on, and they are thoroughly documented in the tests. Private interfaces can change, are unsafe, and are probably not referenced in the tests. And they're also not expected to be sent by other objects, and they don't handle implementation details. So this is where the other two chapters come in with responsibilities and dependencies. So like I said, public methods should read like a description of responsibilities. The public interface is a contract that articulates responsibilities of your class. So does anybody have anything to contribute about public or private interfaces and how you might use them? Or, you know, examples of where you've used them before or gotten burned by a bad use of them?
I use them on every class that I write.
Okay.
The private and public.
Do you ever like try to use gems and stuff or try to use other people's code where it just doesn't make sense?
I try not to use, like you can open up a gems code and look at the private methods that are in there, but I usually try to avoid doing that unless I'm trying to fix like a broken gem. Right.
Have you ever had to use a private interface before, like with somebody else's stuff?
Usually if it gets to that point, I just give up on using their interface and try to write my own.
It's probably a good call.
It's possible to do.
Right. Yeah, I think she gets into that later where it's possible, but it's just harder. But you don't want to do it anyway.
Well, and it's inherently not stable. Like if they're not keeping their gem maintained well enough that you need to go in and mess with their private methods, then you probably don't want to be using that gem anyway.
Right.
Does anybody use any APIs? And I guess what's your experience with that? I guess how is it related to what we were talking about now? I guess.
Well, I mean, my experience with APIs is so far it's just been ones that return like JSON and XML, and in that case, like this is not a relevant issue. So, like, I have limited experience with APIs in that regard.
Okay.
Yeah, I haven't done much with APIs either, except for very basic things. I've definitely seen, like, I haven't written much of Ruby lately, but I've definitely seen, like, at first when I was first reading code, I saw people writing out, like public and private, and that really confused me because I wasn't sure if it was actually hidden from everybody else. But like, it's not completely hidden. It's just harder to get to, and she does go into that.
Right. So, and I know some gems are effectively like wrappers around APIs. So, like I've used a few gems that were wrappers around APIs, and they would send you. I think I use geocoder. I think is a gem that's a wrapper around an API. But I haven't ever had to go and mess with their methods.
Right. Yeah. I think ideally with a gem you wouldn't have to, right?
Right. But gems can be like treated as APIs in some circumstances.
Right.
Like, what's the difference between an API and a public interface, though? Like, I don't really get it.
Oh, okay. So public interfaces, it's not just talking about, okay, so in a gem, for example, the public interfaces are the methods that you can call on whatever, like whatever methods it gives you that it lets you call. And it may have some what are called private methods buried inside of that gem's code, or inside of that gem's code. And to even know what those private methods are, you would have to send like specific kinds of Ruby messages to it that are not kosher generally, or you would have to go in and look at their code and try to find the private methods. So like they're methods that are used inside of the gem, but are not expected to be available to you.
Okay.
And you use that's something that you want to do inside of your own class methods too. It's not just a gems thing. It's methods that you use inside of your classes that are only going to get used by that class. You don't expect other classes to be able to call that method.
Okay.
That's the difference. So public interfaces and private interfaces isn't just for external APIs. It's also for your own internal code. It's the public interface is what that class object considers public for the purposes of other objects.
Okay, cool. So it's a bit closer, I guess.
Yeah.
Yeah. To the middle.
So yeah. So okay. So Mary-Katherine was talking about it a little bit when she first got started writing. Do you have an example real quick of a private method?
Not off the top of my head. I think there was something that you guys did for the Ruby blog, right? The Ruby Monday blog.
Yeah, I've got code right here. I can show you that's got private methods in it. Quick.
I've used private methods a lot in models where I want to do a before action or something like that I just want the model to do something privately, to set up a database or to do something else that I don't want somebody else to pass in and access externally.
All right. Let me see here.
I mean, I guess from the chapter, the prepare trip would be more of like a public interface.
Okay, so let me pull up, I'm going to post a link in the chat, and then I'll share my screen too, some code that I have that uses private methods. And just kind of show you what we're talking about here. Okay, you see what my screen here?
Yep.
Build tracker. Okay, so this is a legislator class. It just takes a JSON and whether it's like the upper or lower house of some legislature, and it finds a particular legislator, and it builds that legislator. So the chamber is public because it's got an attribute reader, and rep data is would be public if it didn't have private written right here on line 8. So private rep data is actually not a public method or a public attribute. It's actually hidden from anybody who calls rep data on an instance of this class is not going to be able to find it. But it's available all the way throughout the code. So every other method is calling rep data and using it, but it's not public to the rest of the world.
Okay.
And then if you look down here, we have another, right here where it says private. Anything after that is going to be a private method. So the filter JSON method is private and can't be called on this object either. So you can describe it as private in different areas. If it's a instance, an instance variable, you can make it private here. If you you can make it private here, or if you don't ever create a reader for it. I like to create readers for all of my initialized methods. And any of these methods for class methods to make them private, I think it's it's something like private class method or something like that. I'd have to look at the documentation, but you can make your class methods private as well.
Okay.
And I'm going to stop sharing now. Sorry. Okay.
Cool.
Okay, yeah. So that was good. So the next section is about finding public interfaces. Let me share my screen again. Okay, so she talks about this. Her example is the bicycle touring company, and she has all these different criteria that go into this company, what they do. There's a trip that can occur several times a year. The limits on the trip are like the number of customers per trip, and they have to have a certain number of guides / mechanics. There's also different routes which are rated according to their aerobic difficulty. There's also mountain bike trips that have an additional rating of technical difficulty that are included in different routes. There's customers that can rent bikes or choose their own. Customers have a mountain bike technical skill level, and there's also bicycles, which are rentals that come in various sizes and are suitable for either road or mountain trips. So those are kind of the criteria in which she starts building out how to figure out what's public and what's private, and kind of working through how to make this into an actual program. So the use case in this scenario would be a customer, in order to choose a trip, would like to see a list of available trips of appropriate difficulty on a specific date where rental bicycles are available.
That sounds like an integration test.
Yeah, so the next part is construction and intention. And she talks about maybe these would be the classes customer, trip, route, bike, and mechanic, because they kind of represent nouns, and they both have data and behavior, which means they're domain objects. But she also, where domain objects, you're supposed to focus on the messages that pass between them and not the objects themselves, which, as a newbie, is not glaringly obvious. So
that's a mistake I make a lot.
Yeah, you'd think with a language that is all about objects that you would focus on the objects, but that's not the case. So basically, she says it's kind of difficult to map these out in your head, and another way to do that is to use a sequence diagram, which would look like this. And this is an example that so there's a customer named Mo. So the two objects are the customer named Mo and a trip, the class trip. Messages are shown as horizontal lines, so where it says suitable trips, that's a message. Arrow points point to the receiver of the message. So in this diagram, it says the single message is suitable trips, and it's sent by Mo to the trip class. Therefore, the sequence diagram can be read as follows. Customer Mo sends a suitable trips message to the trip class, which is activated to process it, and then, when finished, returns a response. So has anybody used sequence diagrams before? Because I haven't. I hadn't heard of them before this.
Nope.
Nope. Well, I think they're pretty neat.
Yeah. Had you ever seen sequence diagrams in UML before? That was something that was totally new to me.
I hadn't at all. No, I didn't know that program existed for creating these. But it makes sense. I mean, like, I'm like a very visual learner, so for me this makes a lot more sense than just having things kind of ambiguous nouns floating around.
I didn't even have a chance to look around before. Is UML like a publicly available open source thing?
I don't know. I think so. I don't know, but I think you can probably just make them
Right.
like on paper, you know?
Right.
Yeah, she doesn't really specify, but she does say that it's seems to be pretty ubiquitous.
There is a UML.org that seems to be the right thing.
So yeah, so after she shows us this sequence diagram, she kind of goes on to say, it's pretty much, if you look at it, an exact translation of the use case, just boxes and lines instead of words. So in this case, she says it seems reasonable that Trip would be responsible for finding trips on a date and of a difficulty, but Mo may also need a bicycle, and he clearly expects Trip to handle that too. So right away we see that there's a message that needs to be passed between customer and Trip that isn't in the diagram.
Yeah, it's a violation of single responsibility.
Right, exactly.
Okay.
Because you would not think that your trip object should be responsible for the kind of bike you would need, or whether or not like bikes are available, stuff like that.
Right.
You would expect to have like a bike class for that, maybe, or something.
Right, but we also have to kind of keep in mind that the customer doesn't want to know any of this stuff. Like, he doesn't want to know that he has to go to somebody else and ask for a bike, and he doesn't want to have to go and do all this other stuff. So he just assumes that sending one message with all the information is he's gonna get everything he needs out of that.
Right.
So yeah, so this is the value of using sequence diagrams to expose public interfaces. And she basically just emphasizes again looking at messages over looking at classes. And then the next sequence diagram is kind of what I was saying before, how in this case he would have to talk to Trip and a bicycle to get what he wants. that's not necessarily ideal.
Yeah, it creates a because the customer, has to send a bunch of, has to know a lot of things about bicycle and trip.
Yeah. So she kind of says, in this case, the customer not only knows what he wants, but he also knows how other customers would be able to provide it, which is going back to the kitchen and the customer example. You wouldn't want to know what's going on in the kitchen necessarily. You just want your food. So same kind of principle here. And so the next section is asking for what instead of telling how. So it's really important to ask what instead of how. So, in this diagram, basically, Trip is asking mechanic a series of questions or sending mechanic a series of messages. And, these are all valid things to ask mechanic. Is the bicycle clean? Are the tires pumped or whatever? But this makes Trip know too much. Trip should not know this much about mechanic. It makes it difficult to pull Trip out and use it by itself, and also pull mechanic out and use it by itself. So they're almost like they're one class, and that's not what we want. So in the next couple diagrams, so in 4.6 over here on the left, he says, well, we should put all of those separate things that we want mechanic to do into a private interface, and just let mechanic write is a private interface.
Yeah. So the public interface would be prepare bicycle, and then the private interface would call all of those methods inside of the mechanic class. All the ones that were having to be called. Go back to your previous screen real quick. So if Trip just says prepare bicycle, and then mechanic has clean bicycle, pump tires, lube chain, check brakes, all that stuff as private methods, they get called inside of the prepare bicycle method. And the only thing that's public is prepare me a bicycle, and then mechanic inside a mechanic does all the things necessary to prepare that bicycle and then spits it out. And then that makes it super easy to go in and change things inside of the prepare bicycle. You could actually, the prepare bicycle method is always going to stay the same, but what private methods get called may change. And Trip never needs to know that. It just needs to know that there's a prepare bicycle method.
Right, and it also just needs to know that the bicycle's ready.
Right. That it'll get a bicycle when it asks for it.
Right. Yeah, so now we've put a lot of the actual guts of the stuff into a private interface in mechanic. So not only does the customer not have to hear about it, the Trip doesn't either.
Right. And then in the next one, she goes even better. She just says prepare Trip, and then it calls prepare Trip on whatever. Like mechanic has a prepare Trip, and whatever else you might need also has a prepare Trip, and it can just call prepare Trip on those, and they'll do what they need to do.
Is that kind of like duck typing?
Yeah, she's getting around to duck typing. She just hasn't explicitly talked about what that is yet. That's going to be the next chapter. She's hinting in that direction in this chapter. She just hasn't explicitly started talking about it yet. But that's going to be the solution that she comes up with in the next chapter. Is what she's getting there now. She's showing the logic behind duck typing now. and then she's going to show in the next chapter how to get there. But that's essentially what Figure 4.7, as far as I can tell, is going to do. Like it calls, so trip has prepare trip and prepare bicycle, and I think, well, I can't tell from the diagram. Is prepare bicycle getting called by mechanic or is it getting called by trip?
Prepare bicycle is being called. It's being called within the private interface of mechanic, I believe.
Okay, so yeah, then prepare trip. That's not quite duck typing because you call prepare trip on mechanic, and the mechanic does what it needs to do by calling like prepare bicycle on whatever else. But duck typing would, she does talk about like not like if it has. I'm trying to see. Well, she hints at duck typing later on in the chapter, I think.
Yeah, I think she does.
Which makes sense because it's the very next chapter.
Yeah. So the next section is about trusting other objects, and she talks a lot about figures 4.5 to 4.7, so I'll just leave it here. So basically she says like this kind of going through these diagrams and like coming to these conclusions it mirrors the stages of development for a novice designer. So kind of your thought process if you are doing this for the first time or just kind of understanding what this design thing was about. She goes on to say that figure 4.5 over here, which we just talked about, trip knows too much, public interface is too large. The two classes are islands. They're a single woven cloth. So the next one, 4.6, is more object-oriented. The public interfaces are smaller. Trip's context is reduced. And then figure 4.7 is, she says, far more object-oriented. In this example, Trip doesn't know or care that it has a mechanic and it doesn't have any idea what the mechanic will do. Trip merely holds onto an object which it will send prepare Trip and trust the receiver of this message to behave appropriately.
Right.
What's the difference between the solid lines and dotted lines? Anybody know? I'm just.
The dotted lines.
Is a response or
well, the solid lines with the arrow are the messages that are getting sent.
Okay.
Right. Yeah, so the solid lines with the arrows are the ones that are like being explicitly sent, and then the dotted lines are kind of.
I think that's like what it's giving back, or
right.
what's coming back.
Like it expects a response that it can use.
Right. So it says it sends a prepare Trip message to mechanic and gets back bicycles, and then for each bicycle, it's calling prepare bicycle, and then.
And also, I'm a little confused about this. Do the thick vertical lines is that a private interface? Or is it...
I'm not sure. I think the I don't know. Like I don't know UML, so
right.
I'll have to look at it and see. From what I can make out of, because she doesn't actually use code in this chapter, she's using this interface. What I can make out of 4.7 is there's a Trip object calling prepare Trip on a mechanic, and mechanic is sending back bicycles, and then it's either for each bicycle, mechanic is preparing the bicycle, I guess, or Trip is calling prepares bicycle on each bicycle that it gets back from mechanic. I think mechanic is calling prepare bicycle on each possible bicycle based on the parameters it gets from Trip.
Yeah, it looks like Trip is just saying, hey, we have this many bicycles that we need, and mechanic's like, okay, I'll run through all of these for each one.
Yeah, at least that's what I would do. I mean, yeah.
But I mean, that's what it looks like to me as well. So, and I think I found the answer to my question that I asked earlier. She says, When an object is busy processing a received message, it is active and its vertical line is expanded into a vertical rectangle. So,
Oh, okay. So mechanic becomes active when it gets to prepare trip, and then it sends bicycles to trip, and trip becomes active again.
right.
And then for each bicycle, it calls prepare bicycle on mechanic again, I guess.
Yeah, I think it loops through each one, so it's calling it
Yeah.
as many times as it needs to.
Yeah. So I think there's two things going on here. There is a finding the right kinds of bicycles, and then there is a getting those bicycles ready. Mechanic's actually doing two different things,
Right.
which I think is part of something that she may be talking about later on. Yeah, I think
we've
so.
got we
got mechanic's doing too much there.
Yeah.
Or trip is one of the two is doing too much.
Yeah. I think they both are. So basically what she ends this section with is I know what I want and I trust you to do your part. So when they send the message, prepare a bicycle, or even just sends how many bicycles they have, Trip expects mechanic to do their part and just trust that it sends the right answer. Blind trust.
It doesn't micromanage mechanic.
Yeah. She says blind trust is a keystone of object-oriented design. So you can't be paranoid.
So Mary-Katherine, one of the things she's saying up here is the blind trust is one of the things that makes duck typing possible.
Right.
Yeah, because it's just going to assume that whatever it's sending the message to has the ability to deal with that message.
Yeah.
And then it's the person writing the code's job to create objects that are versatile enough to deal with those messages regardless of what kind of object they are.
Mhm. Yeah. So that makes sense. So, and I think we've kind of alluded to this, but like I just said, you have to blind trust or whatever. Then this is the final. I think it's the final diagram.
Yeah, it is.
Yeah. So this is the final diagram. This is the one that she gets to, and you can see that the customer just puts in his information and then gets everything he needs back, and there's nothing for him to think about. Trip Finder calls both trip and bicycle once.
Right.
But those are also, each of those are only used once. So if you look in the last diagram, there's a lot going on here where they call multiple times, and I think she's trying to avoid that with this.
Yeah, she's creating like a wrapper object. I think that's kind of what Trip Finder is doing. Trip Finder is like a wrapper object that takes the parameters that the customer wants and then sends messages to all of the classes based on those parameters.
Right. Yeah.
I guess class trip and class bicycle are decoupled.
Right.
They don't.
They don't talk to each other at all.
Yeah, because the trip doesn't necessarily need to know how many bikes. Right?
Mm-hmm.
Yeah, so and this is kind of where my PowerPoint breaks down. But we still have like half the chapter left, or a couple pages.
I think that was pretty good. It didn't seem like it was missing too much.
Yeah,
I think the only thing we really left out was the law demeanor stuff.
Yeah, there's still a couple. And she goes, I wanted to type this out too, but I, again, ran out of time. But the next section is called Writing Code that puts its best interface forward. And she says to do that by thinking about interfaces and create them intentionally. creating explicit interfaces. Every time you create a class, declare its interfaces.
Right.
She also said methods in the public interface should be explicitly defined as such, be more about what than how, and have names that, insofar as you anticipate, will not change, and take a hash as an options parameter, which I don't really understand. Can someone explain that last one?
Yeah, the hash is an options parameter. It's it's I don't know if a good example to show you because I don't do it enough.
And that was from like one of the earlier chapters. How when you're like passing a wheel, and then there's like the rim and the diameter.
Well, I think it was in a method you passed in the options hash, right?
Yeah, that's what she said is so like initially your method depends on the order. So the first argument would be like for example a rim, and then the second argument would be the diameter. And so the method would take. She was saying how that's kind of making your code a little rigid because then how do you know what argument goes first and which one goes second? And then she's saying instead of having an argument that depends on order, instead you have a hash argument that's where you explicitly say rim and then hash rocket whatever value, and then you have diameter whatever value. And so she was saying like initially you're actually your arguments now have to have the key. You have to know the key in advance, but at least it's explaining a little bit more about your class and how it interacts, as opposed to the other option where it was order dependent.
So that's actually arguments in the initialize method. When you actually initialize the class, was it again an example I think she gave earlier? Is that what you're talking about, where you set the instance variables based on a hash? Is that what you're getting at?
Yeah, so that's what I was thinking. But
so that's great, but I don't think that's what she's getting at here, because she's actually talking about with your public interface methods. So any method that you call on. Okay, so let me look back a little bit at her figures here. So, for example, customer is going to have a date and a difficulty and whether or not they need a bike, and they're going to pass that to trip finder. And then, so customer may initialize a trip finder class and then say on date and then pass an argument, and then of difficulty and pass an argument, and then need bike pass an argument. Maybe I'm thinking out loud here.
So yeah, I think instead of depending on order between those three, she's saying to explicitly say on date hash. So that's passing.
Well, that's even assuming that she wants that to be in its initializing. You might just initialize a trip finder and then call those methods on trip finder if they're needed. You see what I'm saying? So like on date you're probably going to always need, but like they might not care about
of difficulty.
Yeah, difficulty or whatever. So like
that's just doing the default value to like all or something, or
yeah.
But it's still kind of the same. It doesn't necessarily need to be an initialize.
Right.
So is she basically just saying that because I feel like the first three in the bullet points she talks about explicitly within this chapter, and then she just kind of throws that last one in. But I think, is that just a way to make it like decoupled from order, depending on order, and therefore more explicit and less likely to change? Like, is that why it's in the public? That's why it's explicitly talked about in the public method, like, or in the public interface.
What figure was it, or table? Where are you in the book? I'm flipping.
77, page 77 at the top. It's like a 4 bullet points.
Okay, yeah, I got it. Yeah, take hash parameters. Yeah.
Yeah.
I kind of think that's. I feel like that's what she means in that, like, your method takes a hash. So you have to explicitly say on date, and you have to explicitly say you have to know the keys of the hash.
Right.
But as opposed to just doing the order entry for the method.
Right. And she talks about that being a way to make your code not dependent. Okay, I think I understand. Yeah.
I'm not sure if this is an explicit reference back to her whether class initialization should take a hash or
Right.
if this is separate from that and on top of it.
Right.
Yeah, I guess. Yeah, I'm not saying it's exactly that, but it's the same concept to me. Like.
Yeah. No, it is. I'm just not sure, like, if she's referring. I'm actually just not sure if she's referring back to it or if it's something that your like methods on your class should also take hashes as arguments, like, as well. Which I guess we kind of do that because we can define methods with keywords now too, just like we can define. Because I mean, initialize is just another method. So.
Right.
I feel like Rails does that a lot too, though. Like when you do like
parameters.
Link 2 is just hash parameters, right? Link 2 in Rails.
Yeah.
So you have your first argument. It does do both, though. I think it's kind of like an order, or you can do like HTML underscore something key, and then your argument after that is, you know.
Mm-hmm. She actually does talk about that, and she doesn't really mention Rails much, but it comes up a couple times in this chapter. I think it's she goes on to talk about the keywords, the public, protected, and private keywords, and they indicate which methods are stable and which are unstable, and they also control how visible a method is to other parts of your application. And there's a kind of like that aside about public, protected, and private keywords. And it's not where she talks about the Rails thing, but she does talk about how putting a underscore in front of methods in Rails isn't often used in lieu of explicitly stating a private method.
Yeah, it's on 78.
Yeah, so I was close.
Yeah, that's kind of cool. I mean, I think it makes sense to like have private methods do all the changes. Then it's just like
I didn't know that was a thing in Rails, like having private methods with the underscore.
Yeah, I didn't either.
I always just used private, like the way Ruby does it with like explicitly saying private or whatever. Of course, I don't know that I've done a lot of private methods in Rails yet. I mean, I've written like pure Ruby classes inside of a Rails application, but I don't know that I've written private methods in like a control. Maybe I know I have written private methods in a control, and I used private to do it. I haven't tested to see if it made them private or not. I guess I should do that.
I wonder if it just. She said, however, many perfectly competent Ruby programmers omit them and instead use comments or a special method naming convention. Ruby on Rails, for example, adds a leading underscore to private methods to indicate the public and private parts of the interface. So I'm wondering if it's not an explicit, like it doesn't actually restrict you, but it's more of just a shout out to the person using it that, hey, this is private. So you can still access it like a public interface, but it's just more obvious that it is a public interface or a private interface. So she also talks about the protected keyword, like briefly. She talks about it very briefly, but I don't really understand what it is. So she says it also indicates an unstable method, but one with slightly different visibility restrictions. Protected methods allow explicit receivers as long as the receiver is self or an instance of the same class or subclass of self. Let's see. Okay, and then the public keyword indicates that a method is stable. Do you have to use you don't have to explicitly state that a method is public, right?
It's assumed that it's public unless you list it as private.
Right.
At least in Ruby, I guess Rails would be the same way. Right,
because I've never seen, in all the code that I've read, I've never seen someone explicitly state public, but I wonder if that would just be like I wonder if that's just like a organizational kind of note to self kind of tool.
See, I didn't even know about protected. I only knew it about public and private.
Mm-hmm.
Protected seems like a weird, hinky middle ground.
Right. And she doesn't talk about it very much, so which makes me think that.
And I've never seen it used.
Right.
But I haven't read a huge amount of Ruby code, so it may be a common thing I just don't know about.
This is where Jesus would come in handy.
Yeah.
Usually he pops in around now. We'll see.
Well, let's just say it was never taught to me by somebody who does use private a lot. So I'm assuming that, and who does like follow Ruby conventions pretty well. So I don't think it's super common, or I think he would have taught it to me.
Right. That makes sense.
How did you learn about the private or your Ruby code stuff?
I have a mentor.
Thanks.
Let's see. Okay, so the next section is about honoring the public interfaces of others. So basically, like I think we brought this up at the beginning, and it says, you know, if your design forces the use of a private method in another class, first rethink your design. And then she kind of goes on to say, like, if you think about, you know, using someone else's code and you thinking, oh, maybe I should use this private interface, maybe just don't use that code at all. So, yeah. But then she also says the next section is called exercise caution when depending on private interfaces. So in the first sentence is, despite your best efforts, you may find that you must depend on private interfaces. So I guess it can't be completely avoided all the time.
Yeah,
but
I think that's a case where you would use a wrapper.
Yeah, basically use all the dependency stuff that we learned in chapter 3. So next is minimize context. Keep the what versus how distinction in mind. Create public methods that allow senders to get what they want without knowing how your class implements its behavior. So try to make your stuff as independent as possible. Right? Let's see.
We get the law of Demeter, or Demeter, or however everyone
I was about to
pronounces
ask that too. I have no idea how to pronounce it.
Everyone argues over how to pronounce it.
Because we always did the Greek god. The Greek goddess was always Demeter. But I don't think it's referencing the goddess, is it?
I don't know. I've heard it both ways, so I don't think there's a convention.
Tomato.
Right. Yeah, because the goddess of like harvest and weed doesn't really seem like a logical jump to Ruby. But
I think the first person I ever heard it from was Avdi Grimm on the Ruby Rogues podcast, and he calls it Demeter, so that was what stuck with me.
Cool. Well, then let's just go with that. Demeter. Law of Demeter is a set of coding rules that results in loosely coupled objects. So Demeter restricts the set of objects to which a method may send messages. It prohibits routing a message to a third object via a second object of a different type. So paraphrased as use only one dot. So don't.
Which is a bad paraphrase in Ruby.
Yeah. It says don't chain methods, pretty much. They're referred to as train wrecks.
But then she gives a case in Ruby where it's perfectly acceptable to chain methods.
Right.
Because there are, like, if you're chaining methods on, like, core classes, it should be fine, because they're not going to That's not going to break your code.
Right. Yeah, she kind of, several paragraphs later, she's like, I gave you 3 examples. One of them was okay. It's like 2 lies and a truth.
Yeah. Okay, and so for those who haven't read it, we should give the 3 examples.
Yeah. So let's see. Well, maybe I can just type it out. Should I type it out? I'll type it out.
Yeah, and I'll say it in the so that people who can't see the chat, or
Do you know what
you're going to
page
put it
it's
on the screen. Even better.
Yeah. Okay. So we've got customer.bicycle.wheel.tire, and this is a lowercase c, not an uppercase c.
Yeah, because it's an instance of a customer.
Right. So the second one is customer.bicycle.wheel.rotate.
That's the really bad one.
Right. And then the last one is hash.keys.sort.join,
Which I'm pretty sure I've written.
Yeah, because that, I mean, she gets into why that one is okay and the others aren't.
I was about to say, I've done that last one a ton. If that's not okay, I've written some really bad code.
No, she was giving an example of why the use only one dot is a bad rule of thumb.
Oh, I got you.
Yeah, that was her example of why use only one dot is not something you should live or die by.
Okay.
Right. Yeah. The next, because the next.
Worried there for a second.
Yeah. No, because that's well. If you notice, so customer, bicycle, wheel, and tire are all classes that we would have theoretically written.
Mm-hmm.
And then customer.bicycle.wheel.rotate is a rotating wheel, which is an action taken on something way far away, which is really bad. But hash.keys.sort.join, hash or keys.sort, that's just going to give us an enumerable, and then .join just turns it into a string. That's all Ruby classes. That's stuff that we didn't write the classes. Unless we're like monkey patching, which we shouldn't be doing anyway, that should all act as expected.
Yeah.
And if I threw you guys know what I mean by monkey patching, right?
Yeah.
Yep.
I do.
All right.
Yeah, so she does say it's a law more like floss your teeth every day is a law.
Right.
So yeah, so we talk about how we just talked about why the last one was okay. Essentially because they're all the same type.
And even the join turns it into a string, but like it's fine because it's like the expected outcome. It's going to do what we expect every time.
Yeah.
Sorry, so is like monkey patching like accessing another class through another class or something, or?
Monkey patching is rewriting one of Ruby's core, writing new stuff on one of Ruby's core classes. So like, it's fine to do it. So, like 2S is one that we do a lot, and that's fine. That's not. I don't think that's technically even considered monkey patching. But if you went and rewrote like the meaning of sort, on enumerable, yeah, if you like went and rewrote the methods, like you can do that in Ruby. Don't do that.
Yeah.
Ruby lets you do it. Don't do it.
Okay.
Note to self: I should not do that because I've actually done that on sort before.
Yeah. Oh no! Don't ever do that. Yeah. Write another method that you call like crazy sort, or give it some other name. Don't rewrite sort.
Got it.
It is funny that they let you do that though.
Right,
like,
don't do it. You can do it, but don't do it.
Well, it's why it's like I think like Rails, like part of the reason why we can have things like Rails and stuff is because Ruby lets you do that kind of stuff. But like, don't do it in your gems, especially. Don't release gems that monkey patch Ruby. Make sure your methods are not methods that already exist in Ruby.
Yeah, that makes sense. I don't think that would have even have occurred to me to like rewrite Ruby methods, honestly.
I've done it by accident a couple of times.
Yeah, I
You
guess
know,
that's very possible. That's
if
something
you
more
don't know if you don't know what all methods are on enumerable, or you don't know what all methods are on string or array, it can be easy and intuitive to at times to define something that already exists, and then things blow up.
Mm-hmm. Yeah, that's a good warning sign or big,
And,
caution.
technically defining sort inside of your class, unless it is not monkey patching, technically, but it's still a bad idea. What actual monkey patching is where you say, like, you open up the string class. So you actually go and say class string, and then rewrite a new method on string or add another method to string. And you can do that, and it's super dangerous. Don't do it.
Yeah, because you're changing all the other objects that depend on
Right.
that.
So like string has a 2s method. That 2s is like the one exception. Like people define 2s in classes all the time.
Yeah.
And string has a 2s method, and people will define 2s inside of their own classes. And I don't know if that's technically considered monkey patching or not. I know it's something that it's okay to do because it's like an expected thing for people to do, but I don't know of any other examples where you define methods where it's considered kosher. And even then, you're not actually going into the string class to redefine it on string. You're defining it inside of some class you wrote. So I don't think technically it's monkey patching. Sorry, I went down a huge tangent. But people need to know about open classes if they're going to write Ruby.
Yeah, I agree.
I don't know the exact term, but I think Q is a keyword. I named I named a model Q, and it screwed up. And I was like, what the heck? But
Cool.
if you see an error when you name a model, it could be, and you're like, what the heck? I've never seen this before. It could be because that is a keyword.
That's good to know.
Like QUEU or QUEUE, or Q
Yep.
is in like the letter Q.
QUEUE.
Yeah, I think it is a class or something. So
I feel like I've always been scared of doing that, and also because I learned JavaScript before I learned any before I even knew what Ruby was, and that's big in JavaScript too, is to not define functions as functions that have already been named or already been used, but there are so many that have already been used, so it's like you end up having to do ridiculous things like, I don't know, maybe I was just being overcautious, but I named all of mine like I appended all of them with my initials because that was just a surefire way to make it unique. So,
interesting.
but probably not best practice.
Or something like that. Like
it worked. Maybe, I don't know. I don't think anybody actually ever looked at that code, so thankfully that was.
We should probably talk about why customer.bicycle.wheel.tire is bad and why customer.bicycle.wheel.rotate's even worse.
Yeah.
Like they're both bad, but why one is more bad?
Is it because you kind of traverse several objects?
So it is. In both cases, you're traversing several objects. You're traversing 4 objects and getting information. You're making like a give me information from tire, which is inside a wheel, which is inside a bicycle, which is inside a customer. So that's bad, but it's just getting information. So it's less bad than rotate a wheel, which is inside a bicycle, which is inside a customer, because it's sending a message to do something really far away, which is a great way to make your code explode.
Right, so basically just the difference is having data versus calling a method.
Yeah. And so the reason it's so bad is because it makes customer customer's not malleable. If it has to know that there's a bicycle and that bicycle has a wheel and that bicycle has a tire. or that wheel has a tire. Like if it has to know all of those things, it's really hard to refactor customer and have it do something different when it calls bicycle.
Can I ask your
Or
opinion?
when it calls whatever. Yeah.
So, like, for example, we have our blog post. I guess it's kind of like in the real world kind of thing. Your controller in the like a post controller, right? You have blog posts. So, like, if you have like a index method or index method, and you show the view, should you pass in two variables, like a post variable and, for example, comments variable, or should you just get the comments off of the posts, or like can you get off of the user? Like, is there like these kind of like heavy rules in that?
So I think, and I think this conversation should be brought to people who are more experienced than us. But I think that is a classic example of where Sandy Metz's principles run into Rails conventions. Like a problem with Rails conventions. So, because she says, or maybe it's not her, I think one of her rules, like one of her hard and fast rules, we haven't gotten that far in the book yet because she hasn't talked much about Rails. But if you follow her rules for coding, one of her things is only ever pass one instance variable into the views layer, and that seems crazy to me. Like, I can understand in principle why you don't want to be passing in, because I guess, like, when Rails first got started, somebody explained to me that when Rails first got started, you had people passing in, like, 20 different instance variables into views, and then things get completely unmanageable. But having, like, passing in, like, a user and, like, so, like, my app has users and bills, and users have bills and stuff like that. But like, what was the example on our? In our blog post, we had posts and
tags
and things like that. So like, it made complete sense to me that posts and tags would each have their own instance variable. So you're not having to call like posts.tags.each.whatever. You could just call like tags.each and posts.each. But I think that would actually break Sandy's rules technically.
Well, but then you said just one variable, though, in a way that breaks the law of the meter. So I guess
like, so there's no good answer. Like if you pass in only one instance variable, you have that instance variable on the views layer has to know to call anything. But like, so if you need to know the tags for the post, you have to call post.tags, and tags is its own object. So there you broke the law of Demeter. But, or Demeter, or whatever. Anyway, but if you create separate instance variables and pass those in, for some reason her rules, we haven't got that far in the book, or I don't know, maybe. It seems to me like the more you read the book, the less the strict rules are strict.
Well, maybe this would make the because she does talk about why consequences of violations. Maybe that's a good time to bring up that so that we could kind of see kind of how these consequences play in these examples, you know?
Yeah.
Like you were saying, like changing tire or rotate.
It makes sense to me. Like so customer.bicycle doesn't seem bad. Customer.bicycle.wheel.tire.each, for example, on a views layer in Rails, that seems like it would be a little excessive. Hello?
Where did everybody go?
I think Mary-Katherine had to run for a second.
Oh, she did. BRB, yeah.
Yeah, actually, I have to go too. But thanks, guys. I'll catch you guys next week and finish the video.
Thanks, Jason.
Cheers, guys.
Later.
Clayton, I'm still here and I still care. If you want to continue, I'm listening.
Well, okay, so you come from other languages. Is law of Demeter a thing in other languages?
It is, yeah. And interesting to hear your point of view on why it's excessive and when to break the rule and when not to break the rule.
How strict is it in like What other languages are you coming from?
I think I come all the way back from ASP Classic, which is that's prior to .NET, and it's always been a rule you don't want to do that. You don't want to keep stringing stuff together. It gets ugly, it gets messy. But then everybody says, no matter what language you're in, well, there's always exceptions to that rule. And I always found that gray area to be complicated.
Yeah. Well, okay. So the rule of thumb
to me, I understand. I try not to do it at all. If I can avoid it, don't do it.
Well, I don't mind doing it. Like, I actually string methods together all the time when I'm manipulating, like, strings, for example. I'll do multiple dots, but each one of those I'm calling for Ruby class methods. I'm manipulating I'm not manipulating my own kind of class. I'm manipulating Ruby, I'm manipulating like a string, for example, a type of thing, and I'm only calling Ruby's core methods for that type on it.
Right.
So like a numerable and string, like a numerable, or like for an array, I'll only call like enumerables and whatever, but as long as you stay within Ruby's core documentation, I think, or core standard library.
But I guess that's a gray area, and not to ask a stupid question, but to me, that's the gray area that I have. Because you were saying in Ruby, as long as you stick within Ruby, well, you can string this, and you can string this, you can string this to accomplish that goal. Why, if you write the code, is that different?
Well, okay, so let's say I actually wrote, I violated this really bad one time. So I can give a great example. I could probably even link to the code.
Cool.
Hang on, give me just 1 second.
And just make sure the question I'm asking is, why is it bad if you do it with your code, but not bad if you do it with Ruby's code?
So
that's what I'm struggling with.
She talked about this in chapter 3, where it's just depend on things that are less likely to change than you are, and the Ruby code probably won't change.
Right. So you can expect that dot join is always going to do the same thing in Ruby. Dot sort is always going to do the same thing in Ruby.
No, it's not, because I overwrite dot sort. We've been over this already. Okay. I'm kidding.
Let me see.
Assumption is.
Yes, there you go. The assumption is that people are not going to do the stupid things I've done. Yes. Got it. That's actually a great answer. I didn't even think of it like that. The odds are that's not going to change. Ruby 2.2.4 is not going to change the way sort works that dramatically, but my code base might. That's actually a good answer. You sold me on it.
Yeah, I mean, she has a whole chapter about it, so,
I'm starting chapter 3. I told you I'm behind. I did 2 chapters in 2 days.
No, that's perfect. I haven't. This is my first time reading it, so I'm still kind of trying to figure out what it all means.
Mine too. My head started to hurt, but I said, I'm going to fall a little behind. I'm not going to get all 3 chapters in. But I will.
So,
we'll catch you up.
Find it here. I have some that do bad things. I may have already refactored it and fixed the problem. If so.
That's cool. Yeah, I know I've done it myself. I know how bad it looks. I just didn't understand why it was such a bad thing in the context of Ruby versus your own. But now I get it. Yeah, it's not going to change.
Well, it also makes it where they're not changing things is the most important thing. So you could do the same thing. You can run into the same problem where if you have a method inside of your so like I wrote a cryptograph system one time that uses a deck of cards to encrypt a string, and it would follow through, you would, as long as you had the deck of cards that was keyed the same as the deck of cards that was used to encrypt the message, you could decrypt the message every time. It was from a book, but I had written, so if I was doing TDD on it, and so to make it easy to test, I was making the first method do something. And then the next method would call the previous method and then do something else. And then the next method would call that previous method and do something else. And so all of my methods were super dependent on all of the methods before them. And so if I made a little bitty change in the first method, it broke every other method in the cryptograph system. And so what I ended up doing is I stripped all those method calls out, wrote then had all the methods do their each individual thing, and then had like what was essentially like a wrapper method that then made all those other calls. And if I needed to fix something, at least the wrapper method, it was only breaking the wrapper method. And so that's an example, I think, of where in theory, it wasn't calling this method dot this method dot this method dot this method, but it was breaking the same principle, where it was saying like all of these methods need each other. If you change one, you break all of them. And so that idea is the idea behind not calling method dot method or object dot object dot object dot method.
Yeah. So actually the last section is called avoiding violations. So I think we've probably already talked about it, but yeah, so the first thing she says is to delegate a message. In object-oriented terms, to delegate a message is to pass it on to another object, often via a wrapper method, which is what you just talked about. So great segue. So she says there's a number of ways to accomplish delegation. So this is where it gets a little fuzzy for me, because she says Ruby contains delegate.rb and forwardable.rb, and the Ruby on Rails framework. Yeah, and then Rails includes the delegate method, and I've never used that and I've never seen it, so I don't know what it is. Do you know, Clayton?
No, it's never been shown to me. She seems to think that it's not super a good idea to use it. Like she says, it's sometimes useful, but beware, it can result in code that obeys the letter of the law while ignoring its spirit. So that may be why it may be. You should know that this exists until you're a high-level Ruby person. Just don't use it and don't try it, because it'll create more problems than it's worth.
Right.
That's my interpretation of that.
Yeah. So the next section is listening to Demeter, and she says it's trying to tell you something and it isn't. Use more delegations. So your familiarity with the public interfaces of known objects may lead you to string together long message chains to get at distant behavior. This is the same as saying there's some behavior way over there that I need right here, and I know how to go get it. The code not only knows what it wants. For this example, it's to rotate was the second code the second line of code we talked about. But how to navigate through a bunch of intermediate objects to reach the desired behavior. This causes all types of problems. The most obvious is that it raises the risk that trip will be forced to change because of an unrelated change somewhere in the message chain. So okay. Eventually she gets to a point where she says, consider what this message chain would look like if you had started out by deciding what depart wants from customer, which also I don't understand where the depart method came from, or what that is. Because she just starts talking about it, but she didn't explain it.
Where are we at here?
Or does she explain it?
What part? Where exactly are you at?
83. It's underneath customer.ride. It says, or it's the first sentence on page 80.
Oh, yeah. Okay. So customer has a customer.ride, right? And she's saying when fast feet changes and begins leading hiking trips. So like if you're going to have a hiking trip, you're not going to be riding. So it's much easier to generalize from customer.ride to customer.depart and customer.go than it is to disentangle like customer.bicycle.this.this.this.
Right.
So you want to have that wrapper method, or that wrapper that just says like customer.ride, because it's a lot easier to adapt that to something like customer.depart.
Okay.
It's just depart is one level higher of abstraction than ride, because customer.ride is a form of departure, but it's not. It implies that you have wheels or a horse or something.
Right.
Instead of hiking.
Okay. So that's pretty much just. That seems like a naming convention distinction, but I guess it's an important one to point out.
Well, I think ride is a wrapper, isn't it? Like she wanted ride to be a wrapper around bicycle and wheels and rotate and all that. Instead of having the message chain, you just have customer.ride, and then it calls all the stuff inside of there that would have been bicycle, wheel, tire, rotate. Or bicycle, instead of calling customer.bicycle.wheel.rotate, customer.ride does the same thing. So it's more friendly to the law of Demeter.
But doesn't that still couple customer with all of the other?
No. It just the customer assumes they have the ability to ride.
Okay.
What causes that to happen? The bicycle and the wheel and the rotation and all that stuff. It doesn't need to know about that. It just knows that it can ride.
Okay.
And then even more abstract, it just knows that it could go.
Right.
If you have customer.go.
I guess just because I don't know if she's gonna break this down into. I think she does break this down into actual code in the next chapter, but I'm just having trouble. I guess I'm just having trouble translating this into actual hard code, like from the sequence diagrams to actual lines of written code. And I think that's probably just because of my inexperience, maybe, but it's also just because I haven't seen any code yet, or haven't seen how they relate to each other yet.
So let's imagine the customer class has two methods. It has a find a trip method, and it has a go method.
Okay.
So the find trip method finds all of the available stuff, prepares the bikes, prepares the bikes. We'll assume like picks the optimal one or whatever. It just prepares the trip, sets it up, and then the customer. Then now that the customer has a bike and that bike has wheels, the customer object wants to take a trip, then it needs to call customer.bike.wheel.rotate to make the bike go. But we don't want to do that because it violates the law of Demeter and it's a big mess and it makes our code unmalleable. So instead, she just has a wrapper method for customer that just says customer.ride. And then that method sends out a message to some whatever and says, do what I need to do to ride. Figure out what that is. I trust you to figure out how to make me ride.
Okay. Yeah.
It's not the perfect analogy, but I think that's what she's getting at.
Right. And I think she does actually start writing it out in the next chapter, which will be good to see. Okay, because in the sequence that she gives the figure 4.8 on page 75, there's just that one method being called. under customer, but she's proposing that there should be another one called ride that is a wrapper that wraps around all the other.
No, she doesn't even necessarily say that. She's just saying, like, let's assume that we have customer.bicycle.wheel.rotate. Like, because we were talking about that with the law delimiter. Let's just assume that that's something that we need to call for some reason. What's a way that we can do that that is not violating the law delimiter? Because that's our customer knows way too much about the fact that it has a bicycle and that bicycle has a wheel and that wheel rotates.
Okay. So you're just hiding the process from the customer.
Right. You're just saying the customer is saying, I want to do something. I want to ride. And then it sends that message out to wherever it needs to send the ride message out and say, I want to ride. And then whatever objects it sends that to, then whether it could be a bicycle, it could be a car, it could be a horse, whatever it sends that message out to, that message is going to know what ride means.
Okay.
And that's where duck typing happens.
Gotcha.
And then she says we can, if ride no longer makes sense, if we have hiking, then we can change it to customer.go or customer.depart. And that does the same thing as ride.
Okay.
It does the same thing as ride, but it's a hike, so ride doesn't make sense anymore. So
right.
We're just creating one higher level of abstraction, and all of those objects, the hike object, or like the hiking trail object, and the bicycle object, and the horse object, and the car object, they're all going to know what depart or go means, but they're all going to do it their own way. They're all going to have their own way of implementing the depart message.
Okay. So
that's going to be what duck typing is.
Okay, gotcha. So you're saying just like, yeah. So depart's just a more kind of catch-all, and if they wanted to change it, they'd be able to. It's just like more.
Well, yeah.
Okay. Yeah, I was
and it makes ride's a whole lot easier to change than customer.ride is a whole lot easier to it's a lot more adaptable than customer.bicycle.wheel.rotate, because that you can only do bicycles. With customer.ride, you can always do something that makes sense to ride. And with customer.depart, you can always do something that makes sense to depart. And so you're looking for that extra level of adaptability.
Gotcha. Okay, that makes sense. So in the end, all the customer knows that they need to do is leave, but there's no doesn't have to know how or what or who or why.
They don't care about any of that. That's what we're going. That's what we want. We want our customer to know as little about what it's sending messages to. It defines the parameters of what it wants to do, and sends that message out, and then it doesn't care about what those things do with that message.
Gotcha. Okay, yeah, that makes sense. So that was our last section of this chapter. So I don't know, do you have any questions, thoughts, comments, examples, concerns?
I think the book's really starting to hit its stride. Like, I think this is where things start making sense for more like high-level coding concepts, not just like simple things like having readers and stuff like that, but like how you really structure your code base.
Yeah, I agree. And because, especially since this is the first chapter where you actually, she goes into the last two chapters talking about the stuff that she talks about there. So it's like, okay, this is all coming together, it makes sense. I see where this is, and some of it.
I think it was smarter of her not to show a bunch of code in this chapter, because what she's talking about is largely conceptual.
Right. Yeah, and the whole message versus object thing, again, is not something that I think would have been immediately obvious, because all of the tutorials that I've ever done with Ruby don't stress that at all. Like, that's never come up. So I think it's really...
This is a high level concept in Ruby. This is not something this is where we're really getting into what OO means to people who have been doing OO for a long time.
Right. Yeah, which is pretty cool. Hoping I can take these and apply them somehow, someday.
I'm starting to see instances of like, oh, I have code that I've written in the last month that doesn't follow these rules and could be better. And like I'm starting, like, up until this point, a lot of the stuff has been like, these are the way I was taught anyway. And now I'm starting to get into high level concepts of either I didn't understand it when it was explained to me before, or it just wasn't ever introduced to me because I wasn't ready for it to be introduced to me.
Right. Yeah. I mean, I still haven't, like, I'm still writing, the apps that I'm writing are so simple that I don't think I've actually even created a class in them yet, because I'm just, like, seeing if I can get stuff, make stuff work without getting into it.
Like scripts with methods and stuff, but not like full-on classes talking to each other.
Right, yeah.
But all of that's going to change with the committed app that we started.
Yeah. Hope so. Pretty excited about that.
Me too.
Hope it I don't know, I hope it works.
I'm optimistic.
No, it seemed like the blog was fairly straightforward, but maybe it was just the nature of having 50 people working on it, but it seems like it got into the weeds a lot.
Are we ready to call it a night on the recording?
Yeah. Okay, so thank you, everybody.
I'm going to stay. Yeah.
In the future and presently. And next week we will talk about Chapter 5, which is duck typing. All right, stopping broadcast now.